databases of the past. So in the first you had navigational databases, which nobody uses anymore because they're silly. And then you have SQL databases, which are based on this thing called relational algebra. And data is like, relations is a sort of thing, is a thing that, an abstract thing that data has. And SQL is just one crude implementation of one way to express relations in data. But there are other abstract properties of data that, aside from relational, which SQL databases aren't necessarily that good at representing. And then, of course, we have NoSQL databases, which are normally like a key value sort of thing. So the original databases were like, you would have like a tree or a tree of sets, and often like to query them, you had to like iterate over the entire set or something like this. Not really very efficient and hard to build things with. And then in the 70s, they invented SQL databases, which you would define schemas and relationships between the data and so on. And they were, at the time, things are very different there. Like disks are like practically free. Computers were way, way slower then. So they optimized the architecture of their databases for like using minimum disk space, which really isn't a problem these days. So now people have moved on to this NoSQL databases, which sort of the hype that for NoSQL came out of the fact that like big, like super scaling web services used them because they just implemented the core absolute minimum that you could do and didn't have all of the sugar on top that made things easy to do with SQL databases. But if you use an SQL database in the same kind of patterns that you use a NoSQL database, then it's more or less as scalable. And then it's also really diverse. Like NoSQL includes a whole bunch of stuff that doesn't fit into what neat category. Like Redis and graph databases are like totally different things. Like Redis arguably isn't even a database. Well, kind of is, but database is much broader nowadays. So, but there's still a lot of things that all of these databases do at the same time and haven't changed. So they all have this like request response API. So you ask a database a question and you get an answer. The database never rings you up and tells you something. This is a bad thing. Like, remember in Hitchhiker's Guide to the Galaxy, the planet Earth is destroyed because the Vogons they had plans to come and build a hyperspace bypass through Earth, and had been on display at the local planning office for 50 years. But humans were never notified of this, so they didn't know they had to go check at the planning office, and as a result, the Earth was destroyed because, and databases are like this, they're more optimized for Vogons than for humans. And so also these are all things like a service that you run, and then, and this is sort of optimized for, like some company can sell you a database and then you run it. And also this is another common principle, is that if there's an extension language or some way of extending the data, it's cheaper to take the computation to the data than to move the data to the place the place where you want to process it. So, so SQL or JavaScript is a popular way to do that. So, what if we invented a new kind of database? So these are the things I think you'd want. So we need this because it's sort of reinventing the wheel, but we're in a new situation where a lot of things have changed. So let's look at this thing, LevelDB. Okay, so if you click on that link, it'll show you all of the open source projects that are part of Chrome, and one of them is LevelDB. So leveldb was written by the guys who made Bigtable, which is what your data will be going through if you use Gmail or do Google search and that sort of stuff. And it's a log structured merge tree, which is this quite clever structure where it keeps all of your, arranges your data on disk so that it's sorted by the key and adjacent keys will end up in order. So if you have a range of data and you want to read out that range, it's actually it's continuous on disk, so you can read that out with a single disk seek. So it's really fast at reading streams of adjacent data. But unlike a file, the cool thing is that there's a way to seek to any point in the thing and just read out a sequence really fast. So if we're going to make a modular database, so there's these two philosophies that are important. The Unix philosophy, which is build many small tools that work well together. And this one is less famous, but the Emacs philosophy is you have a tight part of your program, you solve the hard problems in C, and then you build on top of that with a really flexible dynamic language that's easy to iterate on. And then you have a community of people who can come up with new ideas and try them out in an easy way rather than do it in C, which is the hard way. So Node.js is a combination of both of these things. So you have the core like IO bit, and the bit that implements the V8 is written in C by really, really smart people. And then there's a huge userland who are just people experimenting, and they're not necessarily less smart than the people who are working on the core, but the strong benefit of this is that no matter how smart you are, you don't actually know what is a good idea until you've tried it. And having a big userland means that you can try everything, and 1 out of 10 projects, most of your ideas are rubbish, but you'll find the ones that are really good. And this is a big part of what's successful about JavaScript. Is you get this, there's some official API, and it gets handed down to you, and usually these are designed by committees, and they suck, and they're ugly, and the DOM API and stuff like this is terrible. But then someone invents jQuery, and it's much, much, much easier to use. So we want to optimize for userland and a small core. So leveldb, so it was used to build IndexedDB in Chrome, but it's much simpler API than IndexedDB. It only has 5 important operations. So first 3 is get, put, and delete, which is pretty obvious. And then you have batch, which does multiple puts and deletes in a single atomic unit. So a batch will either succeed or fail, but it won't half complete. So it's like a simpler thing you'd use to build transactions. So there's many important uses for batches. And the other thing is you can read ranges of data out. So you can create, and we've implemented this in LevelUp. You get a node stream, which is exactly like the event stream that Philip was showing us yesterday. And so you can read range of keys forwards and backwards between 2 places. But we can build all kinds of cool features on top of leveldb, because we build it, instead of running it as a service, one of the strengths about Node is that you can, it's really good for building services. So instead of running a database as a service that you connect to with a client, just install it inside your application and build your own service. And then you can intercept everything that's going in and coming out. So then we can do crazy things like have a live stream. So you do a query, but you tell the query, just tell me what's in the database between these ranges, but don't close, stay on the line and tell me when anything new comes in after that. So most databases just don't have this feature. The only thing that comes close, and thing that was a big influence on me was CouchDB has a changes feed. And that's really cool for all sorts of things, but unfortunately, it's only for the changes feed. It was built to do replication, which was one feature of CouchDB, but this is actually my favorite thing about CouchDB. But unfortunately, it was sort of limited to that, and you can't, for example, you can't tail a view and get the results of a query as they change. You have to sort of tail the whole database with a filter. Yes?
We'll get that soon.
Oh, you'll get that soon.
Working on it.
Yep. It's this stuff like that really easy to just like add in LevelDB because it's just inside Node. If it was Erlang, I might still be working on it too. So MapReduce as well. So you can do a MapReduce. You just pass in a database, pass in a function, and a reduce function. That's good for like aggregation kind of group by queries. We can query that. You create a read stream, and then the range can be, say, example here, we're grouping by, we're emitting the key, that's some property of the object, and we're counting how many things have a certain value for bar, and then we can read it back. And if you pass in tail is true, then the connection will stay open, and you will continue to get live changes from that MapReduce. So another thing databases have is you have multiple types of data, and you want to better like put, this part of data here and this part of data here, and you want to separate these things. And when I first started playing around with this, I was doing things like the MapReduce, but you wanted to have multiple MapReduce views, and then they had to store different sections of the database, and it was really kind of every thing that I added had to manage these ranges of data and decide what range it was working on. And then I realized there's got to be a simpler way of doing this. And so I came up with this thing where you create a sub-database. So you add this, this sub-level plugin to the database, and that adds this sub-level function. And then you call sub-level and then a name and prefix, and it returns you a new database object that has the same API as a regular LevelDB database, except it's only a subsection of the whole database, and everything that goes into that will be prefixed with foo. So you can create a subsection of a database, and then you can add new features to the subsection. So you can make a module that mutates part of the database and adds new features and does stuff like this. But then you can use multiple modules together without them interfering with each other, because each one is partitioned to just a subsection of the database. So you can add all sorts of crazy new features, and you can use different versions of the same module and all kinds of things that you've never been able to do with any other database. But it's easy to do this sort of stuff because it's just in Node.js. So we can iterate on all the high-level features with JavaScript. So you can just you write a JavaScript file, you install some modules, you open a database, and then you just plug in the new parts that you want, the new modules that you want, attach them to your database, and now you've got your own database. So there's some things that you can do with this that it's say you wanted to trigger some code to execute when something happens. So this is what it looks like if you want to do that with SQL. So this is my favorite SQL feature. You can reassign the delimiter. So if you don't like semicolons, you can tell it to change to something else. And in fact, you have to do that when you have nested expressions. So here we have a trigger, right? But the way the parser works, so the trigger has some code that runs inside the trigger, and it has to end in a semicolon. But if you had two semicolons within one expression, then it gets confused. So you have to tell it to change the delimiter, then write an expression, then the internal one uses the semicolon, then you end the outer expression with the pipe delimiter, and then you change the delimiter back. And I don't know about you, but that's mental. That's completely stupid. Like, it seems like probably what happened is once upon a time the guy is working on the triggers thing, and they're like, we're gonna get this feature out before Friday, and he was like, oh, I'll just use regular expressions, and then it shipped, and we're still left with this, and this is pretty much how it works in all of the databases. And that's insane. JavaScript has a few quirks, but this is completely ridiculous. We can do better. We can do better than that. So here's a hook for leveldb. So this executes before a put happens. So whenever something is inserted, you get this change object that tells you the key and the value and what type of operation it is, if it's a delete or a put. And then you can call this add method, and you can pass it a new value that will also be added to the batch. So if you do a put, and then you're like, oh, I want to log all of my puts, you just save that with a new prefix and the current date, and whenever you put something into the database, now you also have what you'll have. Notice we're saving the value as, the key as the value, and then the time stamp as the key, as this key. So we can say, so whenever you can query this and see what key you updated at what time. And we just added that feature in 7 lines, which is pretty quick. And then, so we can also add this into a subsection of the database. So we create these 2 different databases, and then we've partitioned the log of all the keys we've added with from the regular data, and we can query them independently without interfering with each other, and so they're really cleanly separated, and we don't need to worry about this. So a question I often get is, why use multiple subsections rather than multiple databases? And the answer is that with multiple subsections, it's all the same database, so you can still do batches across multiple sections. So you can get you can atomically update multiple pretend subsection databases, but you couldn't do that with multiple separated databases, because you could be doing, because all the writes are asynchronous, so one write could occur, one write could succeed, then you could crash, and then the other write will be lost. But if it's in the same physical database, then then either the whole batch succeeds or the whole batch fails. People are often tempted to use a colon to separate parts of their keys, but this is kind of a bad idea, because if you notice, we get a whole bunch of the ASCII characters, we sort them. Colon is sort of in the middle, so that creates some weird effects. So if you have, it means that the parts of the key won't sort in exactly the same order as they would on their own. So if you have AAA1 and AAA colon, then so numbers are before the colon. So you will get, even though AAA1 is a longer string than AAA, it will sort before it because it compares the 1 with the colon. So we don't want to do that. We want to instead use, if you use a really early separator, so the null, so binary 0, or if you really want a visible key, then using an exclamation mark is before all the other non-space characters. So that
there's actually ASCII field separator characters.
Oh yeah.
That's the end of the range just for that.
The high range?
Yeah.
Oh.
There's 4 of them. 1 for record, 1 for line, 1 for file.
Right. Okay. Well, that would maybe so the leveldb has a pluggable comparator. So that could be an option, but we've done it this way because it just works and we don't have to do the C. But that might be a good technique as well. But as I say, we're just mad scientists who are experimenting. So I'll look into that, thank you. So, so having a low separator and a high separator are both useful. So the low separator means that the prefixes will, you can sort by the prefixes and everything will behave as if they didn't have a suffix. They'll still sort the same. And if you have a high prefix, this is the technique we use to separate the subsections. We wrap the prefix in FF, which is 255. So that's when you compare those with other characters, that's always, so they'll always end up at the end of the database, and you can search everything before that and not get the other subsections. We could also put them at the start, it wouldn't really matter. So you can read a range like this using the high and low separators. So we'll use the exclamation mark and we get, so the entire subsection that starts with AAA, and then we can say, get everything that's a subsection of that by using tilde to make the high character at the end. And then we can just pass that to another stream and process it. Yeah, so batches are really, really powerful, and you can build a great bunch of stuff on batches. Say, for example, you wanted to do some asynchronous processing that's caused when you insert some data. Then you can't necessarily intercept the thing and do the job. You have to, like, say, for example, you publish some code or something like this, and then you want to run a test, or you want to do something that's going to take some time, could fail, and you want to do it. You need the best you can do is that you do it at least once. So you can do this thing with a trigger. So how this works is when you insert something into a key, if it's in the range you're interested in, then you change the batch so it's like this data is going in, and there's another bit of data that's going into a like to-do list section of the database where you're like, I have to do this job, and then that will be saved or not. But if it's saved, then you start working on the job, and then if you finish, you save the result of the database, of that job, along with a thing that deletes the job. So now the data is updated as a result of the job. But if you crashed partway through doing the job, then the to-do note would still be in the database. So when you restart, you just start doing it again. And so you'll be guaranteed to do it at least once eventually. So it's important that the job is such that it won't make any difference if it runs twice. So if you're processing a payment or something like this, you need to have some way of checking if you've already done the payment. Otherwise, you'll end up paying for things or charging things twice. So, of course, all data has relations. Well, not all data, but relations is a thing that data has. So in SQL, you do it like this, pretty simple. So Twitter is just a join query. Like the whole thing where it's like, you have all these tweets and you have followers and you're joining the follower table with the tweets table. Of course, if you directly implemented Twitter like that, it wouldn't be very performant. But in an abstract sense, like if you were a mathematician writing proofs about Twitter, this is what Twitter does. So how would you implement that with join sort of thing without SQL? So you can also call it a fan out. So when you do when someone tweets, you copy that to all of the other feeds. And that's basically how Twitter does it, but but it's the same thing as a join here. So first thing is we need to structure our data into ranges. So let's say for each author, we store the tweets by like author, then tweet, and then the data. So here's some tweets that people have made. And then we have a section of the database that's about who's following who. So we have the for a user so we want to be able to extract for a given tweeter who is following them. So we store them as like prefixes, and then and the key is actually enough to do that. And this is just like a join table as well in SQL. So we just use the keys, and then you have a feed table. So the feed table is for a given follower, the tweets by their timestamps, and then the authors, so that if two people tweet at the same time, it still comes out, right? So you save all the tweets. You save them more than once, but the thing is, disks are really cheap. So you would save a tweet for in a section of the database that represented the author's tweets, like what they had said, but also everyone who's following them has a section of a database somewhere, and you copy the tweet to all of the followers' databases, and then when they try to request their feed, it just reads that instead of having to go off everywhere and do. So it's basically you do like a preemptive, an eager join. So like to do things fast. Nothing is faster than fast. So you have to maximize doing nothing. Do nothing as often as possible. And there's two ways to do nothing as often as possible. And one is being eager, which is do something first and then do nothing. Or there's laziness, where you do nothing first until you know you have to do something, and then you do the thing. And I think everyone is probably pretty experienced with laziness. Eagerness feels like more work, not necessarily in the long run. So this is eagerness. So my favorite example for eagerness is, say, when the zombie apocalypse happens, you want to have already gone and bought your chainsaw, because if you go down to the hardware store to buy your chainsaw when the zombie apocalypse has occurred, they're probably only going to have spatulas left, and that's not going to be very fun for you. So this is just like that, except we're going to copy the tweets to the people's databases before they want to read them. So basically, we have a hook trigger, because this will be asynchronous, so that when data is inserted, we get the key. Then when we get the time, we go and read that tweet out of the database, and then we go read all of the followers for all the people that are following the person who just tweeted, and we copy the tweet to all of their feeds. And then when we're done, we go back and delete the note that we had to do that. So even if we crash out partway through that, we'll do it again, but it'll eventually work. So this is something that that's how you would do it. You could also write a module that did that for you, and then it would only be like 1 or 2 lines. So here's another thing that's really good to do is for laziness, is replication. So if you can put the data where it needs to be before it needs to be done, before it needs to be read, then you can just get it locally. So this is more doing nothing. So here we can create a server, and then we can apply this like master plugin, and then that will save. That's like the example I showed before, where we kept a log of when all the keys were changed. So then the slave gets it gets extended as well, and we pipe them both together. So this is called the duplex pattern, where a stream is piped to something and then piped back to itself. And that's just like, that seems strange that way is it talking back to itself, but that's exactly like a telephone. So like one end of the telephone is next to your mouth, and the other end is next to your ear, and you talk into it, it goes off to some other guy, and then comes back. And basically here, the server is answering the phone, and the slave is calling the master, and they're both talking to each other. And I can show you a demo of this. So we'll just start randomly generating data here. and we can connect to that, and notice they'll be in sync. But if we disconnect the slave, the master will continue to generate data. And then if we connect, the slave will be like, well, this is where I last heard from you. The master will send all of that data quickly, and then they'll go back into sync and just update in real time. You can do the same thing. So this is used for a whole bunch of things. So like you could have write to a single master and then fan out all of that data, and then maybe have something like, say if you had lots and lots of people needed to read, they could, you would load balance the reads across all of the slaves, and then you would just send the writes to the master, and then they would fan out. So that would, that's one approach to scaling. Or you could do another thing, used for a totally different problem, where you have writes to all of the masters, and then do some aggregation with a MapReduce, and then you fan them into a single point that does another MapReduce, and then you have global data from like all over the world or something like that. Both using the same module to do the same thing, to do very opposite things. So also you have, you could do master-master replication, which allows writes to either end, which is just like the example from the talk before. Now that looks nearly exactly the same, except with using master there as well. Now I should admit this is actually Dream code. The other one's implemented. This one will be next week, something like that. The important thing with master-master replication is that your database, your data has to have the right kind of structure. So if you have if two things are able to overwrite the same piece of data, then you need to have some way of merging that into a new kind of data, or have some way of deciding who's going to win, something like that. Or if it's a situation like in Twitter, where only one person can write to each section, like only you're allowed to tweet for you. So that just works simple because data isn't actually colliding. And the other thing is like a delete has to be an update, because if you try to replicate like a hole, you have to have something to like show that there's a hole in the data there. So you have to delete by sending a message that says that thing is deleted, and here's what its ID was, and please delete it from your database too. Yeah. So we have a module for full text search. Oh, I said that disclaimer just before. Yeah. Half of that last thing is implemented. Yeah. So one day I was like, oh, we need full text search. So I implemented full text search, pretty easy. It just uses the MapReduce thing, but with a few customizations to make it more convenient for searching. And you can use custom bits that split or stem the words, and you can query it for a slightly different API that does mergers and stuff. So you can search for multiple words, and it will return you all the documents that those occur in. Or you can do a create query stream and send in search terms, and it will stream back all of the stubs of all the documents that match those things, and you could easily pull out the bit of the document that matches and have a search results that shows the little bit of text around the matches, which is really handy. And this is something that I think I made in a day or something on top of other stuff. And this also has the features where you can, or it can when I need to implement that, where you do a live tail, so you can search, and then you can search and you can tell it to stay. You can leave that window open, and you can go and add a document that matched the search, and it will just appear in the search results. So I'm not the only person doing it. There's a whole bunch of us. So this guy, that's not actually a photo of him, but that's his profile. So he started the node binding, which is called LevelUp, and later we split out level down, which is so level down is the C binding that brings leveldb into Node, and then level up is some high level sugar that makes it a little bit nicer to use and a bit safer. And we split it out so that it would be kind of like how you have Express and Connect is like the minimum core, and Express is like the high-level features, but you don't have to use the high-level stuff if you don't want to. And this is actually getting really interesting because level down has like, being separate, we can focus on objective criteria like performance and correctness for what should be in that module. And then the things that we want in level up are more subjective, but we can separate that stuff out and we can all easily agree on what goes into level down. And also a really interesting thing here is the test cases. So level down is written in C, but the test cases are written in JavaScript. And we can actually reuse the test cases to test other bindings that give you a level down API in other situations. For example, in the web browser, we can't add a C extension, but there's IndexedDB and there's local storage, and we can just polyfill that back to LevelDB. So we can get IndexedDB, which is based on LevelDB, and then we can turn it back into LevelDB because that's a much nicer API than IndexedDB. So we just turn it back into LevelDB, and then we can use all of the plugins and modules and stuff that we've written that work on the server. Now they work in the browser as well. And another thing that Rod has done is wrote a module called levelbot, which is really good. So levelbot is an IRC bot that tells us in our IRC chat room, which is #leveldb on Freenode. And if you're interested in that, definitely come out and hang out there. And levelbot tells us whenever someone publishes a module that depends on LevelUp. So we're like sitting here in our IRC chat room, we know like everything that's happening, and I always go off and like read the code of anyone who writes a new leveldb module, encourage them to come and collaborate with everyone else who's working on the stuff. So Julian Gruber, he's a German guy. He's done heaps of good work. So he built this thing, multi-level, which is a remote client. So you can have multiple processes connect to a LevelDB database remotely. So over any stream protocol, like over WebSockets or over TCP or whatever. And that works so you can connect to a database on the server from the browser, and you can connect to multiple databases on servers. LevelUp is another version of this, another take on the same thing, but with a more focus on simplicity and performance. He's also doing lots of work on benchmarks for LevelDB, and LevelStore, which is an interesting thing for storing files into LevelDB, but storing them so you can stream them back out. Paulo Fragomeni is doing lots of work. He's working on LevelWeb, which is a like admin interface, and you can look at your data through like a web interface, and Lev, which is a command line tool for querying your databases. He was one of the co-founders of Nodejitsu and is now working on a new startup called Ocular that does, it's going to be like generic database visualizations where you plonk in your data and have like, he's very influenced by the Brett Victor stuff, and is sort of trying to bring that to like big data stuff. It is now. And Max, so he's doing like, his main project is voxels at Voxel Games, but he wants to, he wrote level.js, which gives you level down on top of IndexedDB, so we can keep all the Voxel game stuff in LevelDB, and then we can replicate it back to the server. And also got the voxels being stored in Level and this sort of stuff. And voxels is another really interesting thing that's like, it's a project that's like post NPM, and it's like, it's kind of a framework, but there's only a few core modules, and then a whole ecosystem that's a whole bunch of other stuff that is just there's tons of modules on NPM that just like voxel something. And those are all, you'll use them together and build games and stuff. And LevelDB is like that. So we often call the ecosystem the level star system, where the star is a wildcard. This guy, M. Carolina, so he turned up, he just turned up like last week, and he's building a graph DB on top of leveldb, and with all the other stuff. Yeah, so some things on the to-do list. ORM mapper, so you can do sort of relational stuff. I mean, the thing is, it's just inevitable. Someone's going to do it. Even a few people will do it, and one of them will win. You don't have to use it. It's not a feature of the database. But it's gonna happen sooner or later because people like that. I bet it'll probably happen before someone implements SQL for LevelDB, but that's also theoretically possible. One of the other projects that Rod did is he wrote a compiled JavaScript language called caps lock script. And it's JavaScript, the loud parts. So it's basically, it's one-to-one with JavaScript, except it's all in capitals. So I don't think you can reassign the semicolon, but maybe I'll make a pull request for that, because that would be great. Anton wrote a thing that makes it work in PhoneGap, so it runs on local storage. Originally we were discussing doing it on top of WebSQL, but it turns out that you only get the same size limit on either of those, and it's much simpler to just use local storage. So it works in IE as well then, except... Yeah, even in an quite old IE, except you've only got... Sorry? I don't know. Yeah, too far. Yeah. The only thing is it only has 5 megabytes, but whatever. So time series data, like some modules for that would be great, and geospatial data would be awesome. And then you could have things like, I'm in this space, tell me when something happened around me, and that will work really well with all of the other real-time stuff. And if you're interested, there's a whole bunch of, the wiki has links to all the modules. Yeah, thanks.